Hi, short video on GCBASIC progress with respect to singles. Oh, I meant singles, I meant floats in reality. Let's look at some code to start with, and that'll really help things, okay? So let me just straight into my desktop. So what I've got here on the right-hand side is a terminal, and that terminal currently is showing some code, and I'm going to edit my code on the left-hand window. So what I've got is a version. Let me just pull that across so we can always see it. I've got editor on my left, terminal on my right, and if I program it, it's just going to program it, then I'll walk the code. Okay, now important is that I'm not going to show you how to program or anything. This is just a capability demonstration for those who are helping with respect to floats. Okay, so I have just compiled a program up. It is build 1344. That's quite important. It is actually the run 445. That means I have compiled 445 programs in this test suite. And that shows out on this terminal up here, which is really good because it's a float compilation test. So you know that what I'm getting on my terminal is actually from my source code. And it says here the time of the compilation, and here is the value, which is actually some sort of mass on the left-hand side. So we can see that working. So let's just make it really simple, and I'll walk you through the code. So basically what I've got is I can define some variables. I can display, and it's called a single, and that has a range, and that range is quite well known, but it is a decimal value of quite a large number, and that's documented. What you can't do is, because I said singles when we started, you can't compile a double because we're testing the singles, so we've disabled the double functionality to make sure that you don't get confused. Really simple. So compile that up. It's a single. I've assigned a value of 1.0, therefore this is a constant. And one of the major issues in the 2021 implementation was that the constants weren't being treated correctly. As you can see, now we have got an 8-digit number on the right-hand side on that terminal, which is fantastic. Now, as we encode numbers, we're going to get a variation from what the number, the constant is, and what the maths are to reality. And we can use, there are many online tools to look at this. And if I look at this particular float, it's a float calculator, I can put a value in here. I can say 127, and it will say that 127 can be represented, and it should always be very accurate because there's no error in the conversion. If I put in pi, 3.142, I'm going to get a slight error here after the decimal points at the seventh. Here we go. Look, it's a very small error. So let me just try and find a number that's actually got some, maybe an integer. No, that's not a good way of doing it. 1.23456. It says here that I'm going to get a small error after this here. Let me just try and find another number that will actually. It's great to have numbers that prepared, isn't it? Really. Oh, that's better. No, we're still not going to get it. So we get errors, and I'm going to try and show you those errors. Okay, so into my program and into bring my terminal up. And what I've got is a whole series of test numbers I can sort of pick and choose from because that's what we've been testing. Let me take this number here of minus 127 back into my little calculator here. And it says that it's quite accurate. So let's put that inside of the compiler and see what we get. Inside of here, I can put that number in there, press function key F5, bring up the terminal, and we should see compilation 448 with a different value. And so what this is showing you is that we can convert constants into a single value, and then there is a function called single to string that will extract that. That's quite useful because that means that you from a device or from an accessory, you can take a digital number, you can do some things with it, and you can actually put it on the screen. And it's very accurate, which is very, very useful. There are certain things you can't do. I showed you doubles, for instance, that aren't supported at the moment. Multiplications aren't supported, but I'll talk about those very shortly. What about this number here? 32,767. I'll come back into my header. Now, there are some limitations with respect to single to string. So what? We'll work on those and we'll publish those ranges as we progress through the testing. But essentially, we're getting pretty good results, and we can now take a constant, put that constant in, and handle it correctly. Now, there were some errors before. There were many errors like this. If you tried to put this number in, the compiler got very confused about what number you'd actually put in. Those errors have been ironed out, and we've done a lot more work in how we actually handle and analyze these constant numbers. Well, here's a good example of a decimal rounding. Oh, that's quite a good number. That randomly put it in. Let's look at the calculator over here, the cross-reference tool. It says in here that the actual number you'll get on the screen is so 6 nines, 6 zeros, and a 9. What did we get in the terminal? 6 zeros, 9 5, 6 0 9 5. Do you know what? That's good enough for military work, okay? That is pretty accurate nowadays. Now, what you can do in here, you can take this value, my single. You can create multiple single value, multiple variables, of course, same as you did before. So my single 2 equals my single 1 plus my single 1. So we're going to do an addition, and we should get an answer of approximately 2.000018. So we can do additions, we can do subtractions, we can assign, and we can convert numbers, which is, well, that's correct because it's actually correct. There we go. It is correct. Yep, that looks correct. So if I add in 3.12 in here, add 3 to it, that would give me a better answer. Oh, I'm still showing the old answer. There we go. Look. Let me just kill that compilation. So I'm now adding 3 to my single 1. I should get a new answer, and I've changed my output on my single string. So we just know things are working. So we should get an answer approximately 3. 4, of course, it's 3 plus 1. Excellent. So we can see that working. You can also do things like this, which is quite clever. If I define my long as a long number, I can then send to the terminal my long number. I can say string 32, that's my long. And I'll show you what I'm going to do with my long in a moment, because we've now resolved and added the conversion of longs. So you can get the integer value of a single by just simply assigning it to a long. So you can say, take a single, assign it to a long. And I have not tested this up to now, but we tested this last week. So maybe we'll see what the result is. We should see 4, and we get 4. There are ways and methods of, obviously now, once you know that value, of how you can then take that value and actually put that and extract the decimal part of the value by multiplying it by a particular number. That's very simple. Multiplications aren't supported, but you can actually do pseudo math through addition. So slower, but it still works. The work in here is progressing. We're working on multiplications as we're speaking. We're also working on rationalizing and improving support for various programs. Now let me just show you a test program I'm running. I think it was this one here. So I'm just going to run a program called 220. 0, 2, 0, 2 numbers deduct. Let me just see if that's the one I want to play with. Maybe it was 30. Oh no, that's good. No, that's good. That was a good one. That was a good one. So what we've got here is a slightly different output. This is the hexadecimal value of the raw information coming from the in memory. So if I take that number there, I can take it over to my calculator. I can put it into here, and it will say the number that was encoded by GCBASIC was this number here, 3.1 3111999999, and in here it's been rounded up to 3.142. So what's this number here? Decimal. That is the decimal component as a hexadecimal representation in floating point convention. So we can extract. What's this number here? We can negate that. We can 3.142 is a negative number, and again that's the decimal point. And this is the result we were just seeing a moment ago at 4. So we have got different methods. We can show that we can assign and create constants, and we can assign those to singles. We cannot create doubles because we're just limiting that. Adds and deducting works well. You can do pseudo mathematics through repeat loops, very easy. We're working on the multiplication and divide functionality. We've already added in, as you can see, the basic core code to get single to a string. We're working on single to hex at the moment, and we'll add a lot more capability as we move forward. That's it. That's what we've implemented so far. A lot more coming along. Enjoy.